What's up, everybody? Welcome back to another video lesson. My name's Mr. Kozad, and I got to tell you that today is a great day to be alive. I'm thrilled that you found this. You probably found this because you either A, you have to learn about logs, or you want to learn about logs. Either way, I'm thrilled you're here, and I hope that this video is helpful for you in evaluating logarithms. So what you're going to learn in this video is, number one, you're going to learn what is a log. Number two, you're going to learn how do we write logs. And number three, you're going to learn how do we evaluate logs. How do we figure out what a log equals? Okay, so let's jump right into this. Okay, so logarithmic functions and exponential functions are inverses. Humbling moment, I just realized that I spelled functions wrong here. Please don't judge me for that. I'm sure you're not perfect either. I do make a mistake once every 10 years, so I'm good for the next 9 years. So logarithmic functions and exponential functions are inverses, okay? Inverse is a key word that we've talked about in my class, and if you're in an Algebra 2 class somewhere else, you should have heard the word inverse before. Remember that inverses are sort of like opposites of each other, where we switch x and y in functions, and graphically what that does is that's a reflection across the line y equals x. Okay, so that reflection piece on the graph is going to be really important when we do the next lesson, which is actually on graphing logarithmic functions. But for today, I just want you to remember that log functions and exponential functions are related. They're inverses of each other. Okay, so before I get into this equation that you see here, I just want to kind of illustrate to you why logs came to be. Okay, so we all know, let's just write a very simple equation. 2x to the 8th. Okay, we all know that we could rewrite the 8 as a power of 2 as 2 to the 3rd, and we could very clearly see that x equals 3. Okay, but what ends up happening here is that is really convenient when you can get both numbers to be the same base. Okay, but what happens when we have an equation like this? 2 to the x equals 5. Okay, 5 is not a power of 2, so we can never rewrite base 5 as a power of 2. But you would probably agree that there does exist a number, x, so that when I raise 2 to that power, x, it's going to equal 5. Okay, we can probably use some deductive reasoning that it's going to be a little bit bigger than 2, because a 2 to the second power would be 4, but it's going to be less than 3 because 2 to the third power would be 9. So we know that this exponent is going to be between 2 and 3, and it's probably going to be closer to 2 than it is to 3, because 5 is pretty close to 4. So let me just kind of illustrate that, because I've probably lost some of you. So here's what I just said. 2 squared we know equals 4. 2 to the third equals 9. So 2 to the x equaling 5. The x exponent has to be somewhere between 2 and 3. And it's probably closer to 2 than it is to 3, since 5 is closer to 4 than it is to 9. Okay, so what a logarithm allows us to do is it allows us to figure out a way to solve for x. And what we're going to do is we're going to use this equation, this conversion here, okay, this relationship, if you will, to go from exponential to a log equation. Okay, so in the exponential side, okay, we've got base b to the x equals y. Okay, so when we take this and we convert it to a log, okay, here's how you're going to write it. You're going to write it log base b. Notice how the bases here and here will always be the same. Of y is how we say that, log base b of y equals x. Now, I have heard and seen several really good ways to remember this relationship here. The method that I use to remember how exponential functions and log functions are related is I remember an alliteration. I remember that logs, here's the alliteration, equal exponents. Logs equal exponents. And here's what I mean by that. When you rewrite a log function, an exponential function as a log function, okay? Remember, the base is always going to be the same. That's easy. But the log equals the exponent in the exponential function. So again, it equals the exponent in the exponential function. And then this y, the answer to the exponential function, goes right here. Okay. Shout out to one of my coworkers and colleagues, Mr. Karam. He's an awesome math teacher, and he has a great way of remembering this that is is admittedly a little cringy, but I'll tell you, you've got to remember your bay. Oh, so cringy when adults use sort of current terms. I don't even know if people say, even kids say bay anymore. But anyway, you know what it means. Okay, so here's how you can use bay to remember how to rewrite a log function. It's base, answer, exponent. That tells you the pattern of where to write your numbers. Base comes first, then the answer of the exponential comes next, and then the exponent comes third. so cringy, but it's great. Okay, it's an easy way. I bet a lot of people actually use this to remember the pattern here. Okay, so let's actually practice writing some of these. All right, so rewrite each exponential function as a logarithm. Okay, so number one, 2 to the x equals 15. So I do not care which method you use, okay, but you're always going to start with log base, whatever the base is. So in this case, it would be log base 2. So then once I go, I've got to figure out where to put these two other numbers. I need an x somewhere and I need a 15. Now the way that I remember it is I remember it that it equals 15 because it equals the exponent. So that means that the, oh, I already did that backwards, sorry. It equals x because it equals the exponent, and the 15 goes right here. So log base 2 of 15 equals x. Let me read that again because this is kind of new for some of you. Here's how you say this, okay? Here's how you say this expression or this equation here. Log base 2 of 15 equals x. That's how we would read that, okay? Now for the second one here, I'm going to rewrite this one using Mr. Karam's trick, the bay trick, okay? So log and then bay, base, answer, exponent, okay? Bay, base, answer, exponent. So log base 3 of 1/8 equals x. Why don't you say that with me out loud, okay? Because this is the quietness of your own home. So nobody's going to judge you for saying this out loud, but I want you to practice saying this so you aren't embarrassed when you have to say it in class. Again, the way we say this equation is log base 3 of 1/8 equals x. Okay, say it with me this time. Log base 3 of 1/8 equals x. Okay, there you go. I hope you actually did that, and trust me, it's not weird. Okay, it's not weird. At least I don't think it's weird. So, number 3, log base is 0.25. Remember, that'll always match the base of the exponential. So base answer equals exponent. So log base 0.25 of 212 equals x. And then we can do the same thing here on number 4. Just because it's all letters, don't freak out about that, okay? Log base a, answer, exponent. Log base a of k equals m. Okay? Super, super straightforward. There's no trick. There's no catch. You just have to remember this relationship here between exponential and log and be able to rewrite them. Okay? Now, we can also ask to go the opposite direction where we rewrite each log function as an exponential function. Okay? So here, the way we'll rewrite this is we'll start with the base. And remember that the pattern here is base, answer, exponent. So base, the exponent would be x, and the answer would be 23. So this would be asking you, what is 8 to the x power equals 23? What is x? Okay. The next one, start with the base. The base is 2. So the pattern that we use for log is base, answer, exponent. So that means the exponent will be x, and the answer is 1 over 25. Number 3, follow the same pattern. Use the base of 0.15 to the x power equals 60. And the fourth one, oh, not log, it's already log. K to the w power equals g. Okay, it's pretty self-explanatory. There's really not much more help I think I can give you on that. You just honestly, if you struggled with that or that, I know it went fast. Go back and watch it again if you need to. But it's really, you just kind of have to practice getting comfortable converting from logs to exponentials and exponential to logs. Okay, it's not a hard concept. Just practice it and you'll get it. Okay, so the last thing that we're going to talk about in this video is problems like this where it says evaluate each log. Okay, and this word evaluate, when you see that in math, that usually means that this is going to equal a number. Okay, that's usually what this means. When the word evaluate means figure out what this value is or what it equals, what the number is. Okay, so what you're going to see here, and these in my opinion are some of the harder log problems because it just honestly requires you to do some thinking. Okay. Now, the nice thing about these problems is that there'll be things that you can figure out relatively easy if you kind of understand how to rewrite these, okay? So, first of all, I'm going to have this, number one, I'm going to have log base 3 of 243, and it's going to equal a number. We're evaluating, it's going to equal a number. So here's the hint that I would give you. Think about this as 3 to a mystery exponent that equals 243. So essentially ask yourself 3 to what power equals 243? Okay, we've been dealing with powers a lot in my class lately, so this might be a power of 3 that you recognize. If not, you could do a little bit of work with your calculator to figure that out, and it shouldn't take you long to see that that would be the 5th power. So we would say that log base 3 of 243 equals 5. And the key to a problem like this is this thing that you're doing in your brain. Think 3 to what power equals 243. Okay? Now, if we do another one, so this is log base 8 of 512 is going to equal a number. So on this one, we're going to think about 8 to a mystery power that equals 512. Okay? Now, this is one that might be a little bit more tricky for you. Okay? We might not automatically know what this is, but 8 to the, I think it's the 3rd power. Okay, I think it's the 3rd power. I don't actually have a calculator on me real quick. So I'm just going to do it the old-fashioned way and do 64. I know 64 is 8 squared. So let's just multiply this by 4. So 8 times 4 is 32. 2, carry the 3. 8 times 6 is 48, right? Yeah, 48. So 48 plus 3 would be 512. So that's true. So 8 to the 3rd power equals 512. So log base 8 of 512 equals 3. Again, you are dead in the water if you do not remember how to rewrite logs as exponentials because you will not be able to think about this equation correctly. Okay? Okay, now let's have some fun with these other ones here. Okay, so log base 1/2 of 16 is going to equal a number. Okay, let me get rid of my scratch work here. We don't need that. It's not important. Okay, so for number 3, what we're going to think is we're going to think 1/2 to a mystery power equals 16. Now there's a lot going on in this one, okay? First of all, 1/2, I'm going to rewrite that as 2 to the negative 1 power to a mystery power is going to equal 16, okay? So what you should think about here is think, what do you need to raise 2 to become 16? That's 2 to the 4th, okay? 2 to the 4th would get it to be 16. But in order to, it's already 2 to the negative 1, so to get that to be 2 to the 4th, I'm going to need to multiply by a negative 4, okay? So log base 1/2 of 16 is negative 4. Now, I kind of feel like I did a bad job explaining that, so I'll try again on a few of the other problems here in a minute. But you might need to go back and listen to that explanation again. Again, I feel like I did kind of a bad job on that. I'm sure you'll let me know if I did. You always let me know when I don't do a great job on something. So I appreciate that. It helps me be better. So sorry if that was kind of confusing, but you really kind of have to know your exponents to be able to, or your exponent rules to be able to kind of track with that. Okay. So we're gonna try again on number 4, okay? So on number 4, we have log base 5 of 1/25 equals a number. And to figure that out, we're going to think, okay, 5 to a mystery power is going to equal 1 over 25. Okay, now think for a minute. I know that I need to raise 5 to a power so that I get 25 in the denominator. Now, how does something move to the denominator? That should be a signal to you that this exponent is going to be a negative number, okay? Since 5 currently is not in the denominator of a fraction, and when I raise it to a power, it moves to the denominator of a fraction, that is a signal to me that this needs to be a negative exponent. That's the only way to move something down to the bottom of a fraction. So then you just have to figure out what number is it. So what power of 5 gives us 25? And that would be negative 2. So 5 to the negative 2 power equals 1 over 25. Okay? All right, let's try number 5. So we know that this is going to equal a number again. And for this one, we're going to think 9 to a mystery power equals 3. Oh, man. This is tricky because we're taking 9, raising it to a power, and we're getting 3. Now, in order to know how to do this, you have to remember, okay, how to rewrite 9. We all agree that the square root of 9 equals 3. We all agree with that. But we have to remember from our last unit, what exponent do we use if we want to represent the square root, okay? Some of you probably remember this, others of you might not, okay? But remember rational exponents. The rational exponent we use for square root is 1/2. So 9 to the 1/2 power equals 3. Again, remember, square root and 1/2 power are the exact same operation. They're the exact same operation. So last one here, and then we're actually done with this video, is we're going to think about 32 to a mystery power equals 2. So again, this is another problem where we're going to have to take a square root. So you've got to think what power of 2 equals 32, okay? So that would be 2 to the 3rd is 8, 2 to the 4th is 16, so 2 to the 5th would be 32, okay? So if we wanted this to be equal to each other, we've got to take the 5th root of 32 equals 2. Well, to answer this question properly, you have to know, how can I rewrite a 5th root as an exponent? And the correct answer there is you would write it as the 1/5 power. The 1/5 power. So my people, that was quick, but that's how you evaluate logs, okay? You think about rewriting them just like we did here. You think about rewriting these as exponential equations, and then you kind of have to use some brain power to figure out what exponent you need to use to get the numbers that you need, okay? So this requires a ton of practice. So please, please, please make sure you're doing your homework. If you want more homework, you can Google worksheets on evaluating logs, and you can find tons and tons of stuff that will help you take care of this. So that is it for me. I will see you next time when we learn how to graph log functions.